Okay? All right. So, so first of all, I would like to thank very heartfully House for inviting me to this prestigious WETO West program for 2014. It's very sorry about that, but I try to keep you awake nonetheless. So I would like to thank President Chameau and Dean Yanou for their hospitality. Also the colleagues I've been interacting with over the next few days. I must admit it was somewhat unexpected, and that was a wonderful part of my stay, because we had only very illuminating conversations, because there are some, as we've hinted at, there are some ideas of potential links beyond this visit, and also because I realized beyond Climate-KIC that when we're going to meet students, and I might be tempted to tell them, have you heard of House? Do you know what place it is? It's one thing to be able to tell them, well, it has a high reputation, go to their website, it's wonderful, but that's an hour. It's quite a different thing to tell them, I've been there, actually, how is the atmosphere, how you feel like, even in a few days in Paris. So thank you very much for your time, for your information and sharing this with me. It's really been quite an experience for me, actually. I must say that it has been quite a nice challenge to prepare this conference. It's not the first conference in Sweden, actually, but this one is a bit special. First of all, I went to your website 2 days ago, and I found the title of this conference. And I thought, well, who on earth can have come up with such a blonde line? And then I remembered this morning exactly, I invented this title. I won't apologize, it's too late for that, but the title did raise some interesting questions. And some of those questions are related to what we are doing. So what can I do? Can I lecture on climate change or on climate? Yes, I might be able to do that. There are much better specialists in this room, so I don't want to ridicule myself. And maybe a bit shorter to make it more fun. So discuss on climate change might serve as a part of the solution. Okay, thank you. Is it better? Right. So you might have seen live or on the internet or on television shows about the climate change. So both sides really. There are some very eminent and world-renowned climate scientists who can have explained that there is climate change, that man has a part in it, that it is an imminent threat, or at least we should start acting now. And well, you know, sometimes there is dimension of Save the Planet, of polar bears on ice, etc. I'm not criticizing, I'm just stating the way it's viewed by general audiences. And you probably have seen as well other conferences by brilliant lecturers who in general are not climate scientists and who explain that there is no climate change, or maybe there is, but man has nothing to do with it, and you shouldn't change your way of life or anything for that. So I thought, well, no, let's not go there, let's not just lecture about climate change. Innovation, I understand that you're all students, sorry, I'm going to speak to students mostly tonight. So as students, you are all breastfed with innovation, and you know all about it in all sides, all perspectives, so I can't do better than that. Then the title there was European Innovation, and if you make a history of European innovation, it can be either very conceptual and a bit boring, or it can be a series of stories and sometimes depressing, because the point is Europe is not absolutely brilliant at innovation in general. Well, I try to challenge that a little bit, but still it's the way we see it. So then I did some soul searching, and I thought, well, what can I bring to you? Well, what I can bring to you very candidly is what Climate-KIC has been bringing to me and to us working there. I mean, we are several dozens of people who are involved in that very curious experiment, and 7 dozens of people paid by Climate-KIC, but also thousands of people in our partner organizations. Most of them could have better to do. I mean, there are corporations, you will see the members we have, and still they are committed for several years and for quite an effort. It's difficult to build something like that. So why are we doing this? Is it because we lack specialists? No, there are in this room, again, better specialists of every single item I'm going to mention. But what we do every day is seeing how they intermingle, how they connect, and how when we talk with our partners, they only have part of the picture. And so it doesn't mean that we are superior and we have the whole picture, but we have to deal with that every day. And that is very exciting. And so, honestly, I just came up with a list of questions I wanted to address, and if I were you, I would like to see addressed today. And that was so long that it would take all night, so I started to cut down, and at some point I stopped because I thought, if I reduce too much, well, you're going to miss the point, that excitement that is being interdisciplinary, that being multidisciplinary, being at the crossroads of something. So just one word before I get really started. I already said there was too much, so let's stop mixing words. But an important thing is why am I coming to Saudi Arabia to discuss climate change? So the obvious reason is because I've been invited. But it's not really a paradox. I mean, you are in, I hope you're aware that you are in probably one of the most environmentally friendly and efficient campuses in the world. And also, you're in a place where disciplines are very strong, but interdisciplinarity, multidisciplinarity, has been at the core of the development from the start. So maybe for you it's obvious. I can tell you in many higher education institutions in the world, even the most prestigious, it is far from obvious, because the disciplines are very strong, and because when you are in a strong community, you think you're on top of the world in that discipline. You don't always want to go to interdisciplinarity, which is not well, not well balanced, not very secure, not very sure. It might be low quality. You're not quite sure of the achievement you're going to get. So, I mean, this is not what Klaus has been thinking. I hope I'm not betraying the philosophy of the place. And for me, it's just natural to be here because climate change is almost all about interdisciplinarity and even systemic problems. So the last two things I would like to say now. The first thing is I'm not here to convert anybody. I think conversion is for faith. And 1 hour is not enough, even if you want to convert somebody. And I'm not here either to give you definitive answers about anything. Again, some people here might be able to give you some. I don't feel able to do that. And what is more, I think the questions are almost more interesting than the answers at this stage. So my only ambition is that you don't take for granted what I'm going to say. You just try to make your thinking independent. You try to get rid of some misconceptions, that's okay, but then start thinking by yourselves. So just one word of warning, you'll see that there's quite a lot of slides and there's a lot written on the slides. So I'm not going to read everything, and I advise you not to read everything either, otherwise it's going to be a big headache. But it's supposed to be a bit for the record if you want to go further afterwards. I hope that this can be a basis for further investigation. So yes, the first question, have you ever met the climate? So this seems a silly question. Well, maybe not so silly after all. What is the climate? I've been warned by one of your colleagues that I shouldn't use that word at all. Well, unfortunately, our name is Climate-KIC. But climate is indeed a little confusing. What are we talking about? Earth, as you may know, is maybe not the only one, but the only celestial body we know which has near the surface water in 3 phases, different phases, liquid, solid, and vapor. And then what is climate? It is interaction of the atmosphere, the ocean, the ice field, the larger glaciers, etc. And one problem, of course, is that climate is often confused with weather. So this seems very trivial, but haven't you heard somebody living in, I don't know, Chicago telling you, well, you can't be serious, there's no global warming because I'm so cold and we're all so cold this winter. And the point is, well, the equations are the same, but the time scale is fundamentally different. The weather is from 1 to 10 days. We know from chaos theory that probably going beyond 10 days is going to be very difficult or maybe impossible. Climate deals with much longer. When I mean much longer, it's not 10 years, it's probably 20 to 30 years. So the approach is not deterministic like the weather, it's rather probabilistic, and we try to, the climate scientists try to predict the trends, but also the multiplication of, let's say, extreme events. And then extreme events, why is this related with climate change? Well, that question is not obvious either. Warming is what you usually hear when you hear about climate. You say that global warming, beyond 2 degrees of global warming is going to be very dangerous. And then you could be forgiven for thinking, well, today it was 28 degrees. If it was 30 degrees, what's the difference? Or minus 20 or minus 18, what's the difference? So no, it's not so much about something you can feel on a day-by-day basis. It's really the quantity of heat you need to warm the atmosphere by 2 degrees. And this quantity of heat, to give you an idea, over the last 15 years, the estimation is that the equivalent of 4 Hiroshima bombs has been released into the Earth's atmosphere every second in the last 15 years. So this gives you maybe a clear idea of what it means. As for specific disasters, well, I don't know how it is in your countries, but in France, we have very good scientists, and when they are asked, well, there has been a major storm in the Philippines, or there is a heat wave or a cold wave in the United States, is it climate change? And they say, well, we're not sure. So after a while, you just think, well, they're warning us against multiplication of extreme events, and they say, well, maybe it's not climate change. I would suspect a better answer would be to say, I'm not sure this storm is due to climate change. Of course, you always had storms on Earth. But maybe over the 20 latest storms, we can have reasons to believe that a few of them were fostered or maybe made stronger by climate change. So you see the kind of space where obvious statements like that can be not so obvious, and that's the kind of things I wanted to tell you. So climate, I'm not going to go into that detail, but climate is not just about temperature, obviously. It's about the atmosphere at the surface, the upper atmosphere. The composition of the atmosphere, you can see here if you are a chemist or not a chemist, you can see that those are the GHGs, that's the greenhouse gases. And you have also indicators on the ocean and the terrestrial part. Just one word you see here, albedo, to define it briefly, it's the reflection coefficient between the radiation the Earth receives, for instance, and the part that is re-emitted. And obviously, the higher the albedo is, the closest you are to a whiteness, so that's why it's called albedo. So the greenhouse effect, I suspect all of you are familiar with that picture. So what is the greenhouse effect? In short, the main source of energy on Earth, it comes from the sun, so the solar radiations come through the atmosphere. 30% roughly is re-emitted directly to the outer space, and 50% reaches the surface of the Earth. Part of it is re-emitted, and then 20% is absorbed on the way by the atmosphere and warms it. So what is obvious as well is that the temperature on Earth is not the same as the temperature on the sun, thankfully for us. And this means that the wavelength of the radiations is not the same. So, in fact, the radiations from the sun are not really captured by the atmosphere, but the radiations re-emitted by the Earth are captured by the atmosphere. And so this creates the greenhouse effect, which is similar to what you find in greenhouses, or maybe in your car if you park it in the sun, especially in this campus. So the greenhouse effect is not all bad. If there was no greenhouse effect, the average temperature on Earth would be probably minus 18 degrees. If there was only the greenhouse effect, it would be probably 30 degrees. So the difference comes from the fact that we have convective movements of the air. I'm simplifying here. I apologize to climate scientists for the simplifications I'm going to make today. Greenhouse is not bad, but it is very vulnerable to human activity because it is caused mostly by greenhouse gases, which are a very tiny portion of the atmosphere. Another thing I mentioned was that solar energy itself varies with time for obvious reasons, the variations of solar activity and also the distance between the sun and the Earth, which varies. But those factors so far have not proven to be sufficient to explain the climate change events recently. So what is crucial in climate is interaction between the ocean and the atmosphere. That's also the part that is less well known, unfortunately. I mean, the influence of the ocean is massive, but it's not completely mastered, so that's one element of criticism against the models. Anyway, what you have to know is that most of the heat hitting the oceans is stored by the upper layers. How much is not exactly clear, but most of it is stored by the upper layers, so they're warmer than the deeper layers. They do not really merge except on some places, and those places are absolutely crucial in climate phenomena. There is a difference, well, there are many differences between the atmosphere and the ocean. The main one is probably that the atmosphere has very fast evolutions, whereas the ocean has much slower evolutions. So the variations for the atmosphere will be found in space, and the variations for the ocean will be found over time. And because the quantities of heat stored by the ocean are massive, those effects can be massive over time. I'm not going into the details on the right. You heard of El Niño, these kind of things. By the way, El Niño is not caused by man, as far as we know. But you see some of the factors that can influence climate change from the oceans. So let's come to GHG. GHG proportions have been remarkably steady in the last 10,000 years until 1850. Since 1850, there has been faster and faster change, and you can see the curve really going up. So some opponents or skeptics on climate change will say, yes, but there's always been change in climate. Yes, it's true, but yes, life might adapt in different forms, but maybe not in the form we know. We're interested in our future as human societies. It might be selfish, but that's what happens. And the human societies, as you think of it, have developed over the last 5,000 years. So this period is very steady in terms of GHG, so there has not been a human civilization going through a massive climate change the way it is anticipated by some. Others will hope that natural factors could slow down the global warming and that there could be a cooling effect. From what I know in discussions with climate scientists, it's not likely to happen in the next 100 to 200 years. So maybe we have to do something if we don't want to land something ugly to our babies. By the way, the drawings were made by a cartoonist. I tell whoever is interested where to find them. So we have to measure GHG. It's absolutely crucial because if we don't know where to focus our efforts, we won't be able to mitigate or adapt properly. And the GHG concentrations, contrary to what you might think, are not monitored through ordinary air control. The main reason is that what air quality controlled is toxic gases, which are chemically reactive. That's the case of CO and NOx, but that's not the case of most of the greenhouse gases. But because they are not reactive, they're going to stay for much longer in the atmosphere. So the main ones are water vapor, which is the most obvious, but maybe not the most frequently mentioned. Why? Because its cycles are shorter, because the research is more under development probably than CO2. What is known is that it reacts strongly to climate change, and if there are higher quantities of water vapor, globally it tends to reinforce the effects of climate change. CO2 is the best known. It has a very long cycle. The average concentrations tend to be quite evenly spread across the globe, and that's why you can do research on ice core, for instance, to measure the concentrations of CO2 over the years. CO2 generation by man is, of course, a minority of the CO2 exchange, but it does affect the balance, and that's why we have to take care of it. CH4 is methane. So methane is in a much lower concentrations than CO2, but make no mistake, it does have an impact because a molecule of CH4 is dozens of times more powerful in terms of radiation effect than a molecule of CO2. And there is some reason to be concerned because, for instance, in Russia, in permafrost, you know, this permanently frozen layer over the ground, there are massive quantities of methane. So if there is strong global warming, this might be released to the atmosphere. Ozone and N2O have a more ambiguous role with climate change, and so I let you read it if you're interested. So as I said, measurement is key not just for GHG, but especially for GHG. Thankfully, much progress has been made, and there are common standards across the world to measure in consistent terms what's being emitted, but still you have different methods and data sources to measure that, which is good because it can allow to compare the data. Just a few words about IPCC. If you are interested in climate change but not a specialist, you know that there is a body called IPCC and giving, well, recommendations to governments. It's not quite that. IPCC is an intergovernmental panel on climate change. This means that all countries on Earth in the United Nations are represented. Every government sends one expert in the panel of IPCC. And it actively involves thousands of experts of all the relevant fields. It does not produce research, but what it does is assess and synthesize the research over the last 5 years to make it accessible to decision makers. So what is in IPCC? You have, well, the panel I just mentioned, principally 3 working groups. The group 1 working on the physical science basis, group 2 on the impacts, adaptation and vulnerability, and group 3 on the mitigation of climate change. So its role is, again, to provide policy relevant information, not to design policies. So the most accessible for a non-specialist like me and probably most of you is the summaries for policymakers. That makes for good reading because you have a number of results which again have been discussed word by word by all the members of the panel, so there is unanimity of the panel on each word. But those summaries for policymakers make statements with an assessment of their certainty. So they don't say, definitely it is like that. They say, well, it is with this likelihood. There can be debate on how they assess the certainty, but it's a good way to introduce a key point I wanted to emphasize. Well, the emphasis is this one, sorry, at the end. the scientific result with an assessment of its certainty or of its doubts is not the same thing as a mere opinion. So why am I stressing that? Because when you listen to debates on climate, you have the impression that you always have to bring a climate specialist and a climate skeptic. The climate specialist will say something, it's supposed to be an opinion, another person comes and states the opposite opinion, and that's just it. You have a draw and you can move on. I mean, that's not the way to approach things. You can have doubts about some of the aspects of what the scientific community comes out with, but you can't confuse a fact with some degree of certainty and an opinion. Just coming back very briefly to this, what I wanted to stress is that IPCC has been criticized, but for opposite reasons. One reason is that, well, climate change does not have only negative aspects. Yes, for instance, if you want to navigate through the polar oceans, it's rather good that you don't have ice. That's one aspect. But it has also been criticized, and it's less well known, because the worst case scenarios do not really appear in IPCC policy summaries for policymakers. They are mentioned in the reports, but not so much in summary. Because, again, the probability might be small, but it doesn't mean that they do not exist. And there has been some criticism about that. So just to show you the pictures, you can find them everywhere, but this is, the first part is images from the IPCC on the observations since 1901. So you can see on the scale, the more purple it gets, the more temperature rise has been observed. This is the volume of precipitation. So in particular, you can see that some dry areas are getting drier and some wet areas are getting wetter. The B is very spectacular. So in fact, the decrease in Arctic summer sea ice has been stronger than expected by even the rather bad scenarios. So that was one of the surprises of the latest report. Concurrently, the sea level change is more or less consistent. And so if you work on scenarios, none of which is the worst case scenario, you can see that locally the expected rise in temperature can be very high, more than 10 degrees. So that's absolutely considerable. And even the scenario 2.6 on the left, which requires a lot of voluntaristic policies, reducing emissions, energy consumption, and really a lot of alignment on that, are not completely reassuring. In terms of global sea level rise, you can see that in this scenario, you can get to up to 1 meter. 1 meter means, I don't have the figure in economic terms, but it means dozens of millions of people potentially affected. And you can't just tell them move. I mean, many of them are poor people who just rush to coastal areas, and the infrastructures are very bad. They're not well prepared for such a change. So climate change is not just about climate science and technology. It's also about a number of other things. So one is societal. If you want to act on climate, you need to have some societal adhesion or at least clarity. And you know, I've been mentioning that there are lots of controversies, and we've been asked, why don't you go into the controversies and tell people how it is? First of all, we're not certain on everything, but second, it's very time-consuming. Most people who have doubts about climate change are not militants against it. They just have doubts because they hear a lot of things, and the best we can do is act and try to give them food for thought. It's also very dangerous to be too simplifying on climate change. That's precisely what I'm doing, but it's dangerous, for instance, you know this superposition of curves between the rise in temperatures and in CO2. In particular, Vice President Al Gore did that. And then very quickly somebody said, but you know, in history, at the end of the last ice age, there has been a rise of temperature before the CO2 raised. Yes, that's true, but then the CO2 has continued rising and the temperature has continued rising. So maybe there was an external driver, that's almost certain, but it doesn't mean that CO2 does not have a role in increasing temperatures. So the key message I want you to remember about that is that, of course, there is uncertainty in climate modeling. But after all, maybe not so much more than in many models we use every day. Just think of economy. I mean, we have to follow some economics models. But are we really more sure of their accuracy and of even their relevance? No, and still we still have to follow some. So this is part of psychology in there. Talking about the economy, not going into any detail again, how is climate change related to the economy? Well, the interesting thing about the IPCC is that you have all kinds of economists there. Some are liberal and think that the market should decide. Others focus on technologies and develop technologies which you will not regret even if there is no climate change. But they all have to come and work together and give some assessments of the situation. The problem with assessing the economic impact of climate change is that you don't always know what to take into consideration. It's rather easy or feasible to assess how much it would cost to invest to mitigate climate change on a certain area. But how do you assess the cost of not addressing CC issues? How do you integrate the lost production in agriculture? How do you address the fact that victims of climate change won't have consuming power, etc.? There is one attempt in that direction which is very famous. It's the Stern report. So it's been challenged, but globally what Stern is saying is that if you do not act urgently, up to 20% of the global GDP, so gross domestic product on Earth, might be lost definitively because of the effects of climate change. So this maybe talks to people who are not so sensitive to polar bears. Another dimension is that you cannot put everything in the GDP. I mean, let's say there is a massive flooding of coastal areas. Are you going just by financial computation and funding to save millions for starvation? Are you going to reduce humanitarian crises to their economic consequences? So I know I'm rather asking questions than giving answers, but what I would like you to understand is that the dimensions are multiple, and addressing the economic impact of climate change is not in itself a simple question. So fortunately, some economic actors are ready to invest in climate change mitigation or adaptation. Some because they think it's the right thing to do. Some because it does give an image, after all, of modernity and reliability. Let's say you're an energy provider. If you can reduce the emissions of your network, that shows that you're technically reliable and not just climate change conscious. And also there is a notion which is more delicate to handle, but it's the fact that low carbon technologies can contribute to individual well-being. GHG reduction does not necessarily mean that you're going to reduce your quality of life. It can go with comfort, it can go with high-tech and life easing. Just the fact to have a driver in times of crisis that is not an obvious one, the fact that you want to innovate for a better, more ecological, more societal conscious society can be one of the powerful drivers when the economy and the finance are not the drivers. Just a remark, climate-friendly societies in Europe tend to be in the north, and those economies are actually the most robust in the area. So I know it's not as simple as that, but it gives an indication that you should dissociate fighting climate change from sacrifice and growth. Another aspect of climate change innovation is whether you should focus on mitigation or adaptation. So mitigation is try to prevent climate change and fight against the causes. Adaptation is just adapt to the consequences, let's say extreme events or warming. So there are pros and cons for both sides. Some say focus on adaptation because the results are immediate, because even if climate change is not caused by man, you still have to adapt to disasters, you still have to react to extreme events. The danger, of course, is that if you only treat the consequences and not the causes, there might be, after all, this global climate change, and then you will multiply the scale and the frequency of these events. So that's more investments, heavier ones on and on. If you focus solely on mitigation, of course, it's the reverse side of the coin. It's not evident to observe how much progress you're going to do, because the effects will be seen in quite some time. But of course, the pros are that you face the problems as they are, as soon as possible with well-thought investments before it might be too late. And also, in fact, some businesses are more interested in mitigation because it's bigger business simply, because the scale of the investment is larger. So maybe it's not a very noble driver for some of you, but it is real. So at Climate-KIC, of course, we have chosen not to choose, and we think that adaptation and mitigation go together. There are lots of technologies which are at the boundaries of the two, and in practice, 1/4 of our activities are more turned to adaptation and 3/4 to mitigation. Another remark we had when we created Climate-KIC was that innovating in climate change was kind of weird thing because there is no market for climate change. You can't name a corporate multinational which is centered on climate change. So they said, okay, it's going to be yet another conceptual exercise. You're going to save the world in 100 years, but in between nothing's going to happen. Well, the reality is that we're just 3 or 4 years old. We have more than 100 companies on board. You'll see the numbers later, and half of them are corporates, half of them are SMEs. What is true is that the economy of climate change is for the moment made of immature, emerging, or very niche markets. And what we have to do and try to do is integrate more and more those small markets into larger markets so that investment is made more synergetic and more profitable maybe in the shorter term. Another problem we have is that we have two drivers, commercial value and societal value, but they don't always go together. Just to give you two examples, you might hate me for that, but the first one is that students have wonderful ideas for startups such as, oh, let's use new energies in luxury resorts. Yes, that's very nice, but maybe you're creating a need that does not exist and maybe society has other priorities. The other way around is more tricky. You can have societal value. Everybody would agree it would be good for society, but no commercial value because acceptability is not there. Let's say sustainable mobility, many people think it would be right to have an electric car, but most of them do not go there because they're afraid of practical details because they don't really know how it's going to work. So, well, there has been some solutions to try to help the market, and one of them is, well, try to work on a carbon credit market. So for this, you can go for details on any article on the web, but to be short, the idea is to give a price to carbon which is measured on the impact it can have through climate change. So there are three principal leads. The first one is simply to transfer energy subsidies from fossil fuels to renewable energies. It's very simple to say, it's much more difficult politically and financially to do. Second lead, the carbon taxes. You tax, in fact, the carbon content of fuels, or you tax the emissions. So there are some mechanisms. It has been experimented by Nordic countries, Finland, some other Nordic countries. I think Australia introduced it, and I think that Australia is going to suppress it. And then the third lead is the cap and trade or emissions trade. The idea is that you are a firm, you are allowed to emit a certain amount of GHG. If you are below this amount, you are allowed to sell the excedent to other companies. So this creates a market, and this gives a kind of market value to the carbon. One example is the European Union's emissions trading scheme. So there are supporters again of the two schemes. Carbon taxes might be more effective with big emitters. Credit rate might be more flexible, and maybe it's easier for policymakers to set the right level of the carbon price. So I think that's enough as well, preliminary material to know what we're talking about. Let's turn to European innovation. Just this photograph is a nice one. We like it. It's the Innovation Festival in Wrocław, Poland, and this show was designed by our hosts. It's actually a water wall, and images are projected on this water wall. So does Europe have a role to play in innovation? So that's another provocative question maybe, but let's reflect on it in just 5 minutes. First thing, Europe is a developed area more or less. Developing countries have, of course, structural problems we all know about infrastructures, educational level not always controlled, corruption, etc. But it also has obvious drivers for growth, which is that everybody justifiably wants to get to a certain level of comfort and of quality of life. So there is, not being too naive here, a wide agreement between the quest for growth and the aspirations of the society. When you come to developed countries, it's much less obvious. Most of us took and some still take for granted that the level of development we have achieved until now is going to stay, that the current life quality is going to stay the same or maybe increase. And yet, maintaining our standards of living with maintaining competitiveness and social cohesion is going to be quite a challenge because of the growth of the other countries, because of the availability of resources, because of many reasons you know. So we are aging societies globally with sophisticated welfare, social protection, drivers for growth, not so clear, not univocal, not everybody is doing the same thing. So we have no other choice than to innovate to keep those drivers for growth. And then what is this strange list of countries? Well, it comes from trips I've made, let's say, in Southeastern Asia. And I talked with parents who had children a bit younger than you and who were in age of going abroad for university studies. I asked them, where would you like to send them? And they said, well, the USA, no surprise, Japan, Singapore, South Korea, Australia, which is really lobbying all across Asia to get the best students. And then Europe comes number 5, 6, 7. Well, this means that the students are not going to go there. So this is a kind of, we know it, but it's kind of shock when you meet it on the ground. And then the question is, what are our credentials in Europe to still try to remain in the race for innovation? Well, first of all, we think that we still have some good science. So this indicator is simplistic, but it's one like another one. Nobel Prizes in physics and chemistry in the last 25 years, so not in a century ago. 87 in the USA, but still 45 in Europe. For Fields medals, you met one 2 days ago. It's 11 in Europe, 8 in Russia, 4 in the United States. Among the 10 top universities for the Shanghai ranking in mathematics, there are 6 American, but still 2 British, 2 French. So we think, okay, that's not too bad in terms of science quality. Does it turn into commercial technologies? Well, in some high technology fields like aeronautics, Airbus is still competing with Boeing, and well, they're exchanging number 1, number 2 spots every once in a while. The first flying helicopter, seaplane, commercial supersonic plane came from France or France and Britain. Fastest trains are shared evenly between Europe and Asia. The smaller ones, some of which you are very familiar with because you have them in your pockets, were created in some European countries. So it doesn't seem that the technology is so bad either. The economics, well, we know that best economists tend to go to the United States, but some of them come back to some European faculties. So it must be more complicated than that. Let's take an example where good research and innovative technology doesn't prevent you from getting into a market failure. So let's take, for instance, solar panels, which is very relevant to climate change, by the way. This market was first dominated for several years by the United States and Europe. And it is estimated, I don't quite know how, but it's estimated that 1/4 of the viable technology was originated in Europe. And yet, Europe only has 6% of the market. Then what do? We blame China for that, and we say, oh, they have low wages, heavy subsidies, so they're distorting the market. Anyway, it's a major failure for Europe, and it can indent, in fact, our capacity to innovate up to a success that would influence the well-being and the economic health of our societies. Then let me quote a paper I found interesting, a recent paper from Energy and Environmental Science, which studies precisely this gap between China and the Western countries on solar panels. And what they say is that maybe the major factor is not wages or the subsidies, but the fact that in China you have a high density of manufacturers of solar panels. And if you innovate sufficiently in, let's say, silicon solar panels, you might decrease the threshold for a manufacturer to invest in solar panel production. And then you might allow for scaling out because you could increase the density, not just in China, but all over the world. So that means cheaper, well, access to cheaper materials. That means less transportation costs, etc. So the example in itself is not so important. What is important is that you have a market failure, that's obvious. But you could have, if you do not analyze closely, 2 completely opposite conclusions. The first one is, give us a R&D in this field, and I mean, solar energy is quite an important field. Or invest again in worldwide cooperative research. So this means that here the life or the death of an emerging sector can be actually decided on rather subtle elements and not as simplistic as it once we thought. There are other examples, and that's rather for some of you who might consider going to startup creation. Well, good technologies can turn into bad products. Bad either because they are not very good or because they don't come at the right timing. Apple had something called the message pad. Does any of you know about the message pad? No, you know the iPad. But in fact, before the iPad, there was a major failure, which was called the message pad. So Apple was lucky they did survive and very well until they launched the iPad, but many other companies just disappeared because they came up with too good too early. And one example, not quite a commercial one, but that's Minitel in France. So people who are old enough to remember know that this was a wonderful thing which allowed you to have a lot of information for almost free in your home, and every single home in France had that. And you had information about the weather, about companies, firms, about products, and so on. It was almost like a rudimentary internet. The only difference is that there was no economic model like the internet. So it never generated the economic impact the internet had. So what could you think of all this? Well, the tendency, especially for a science student, I think, is that if you want to launch a startup, you want to be sure of everything. You want to have the very best perfect technology. And then if you have this, it should be a sequence of logical steps and you will become rich and famous. No, it's not the way it's working. So that's something those examples should make you think of. But there are key abilities which are not directly related to technologies, which are capacity to anticipate non-tech bottlenecks. And for instance, the fact that the market is not going always to react the way you expect it to do. And some companies do succeed ultimately because they're able to find very quickly new uses for their technological breakthroughs. And that's something you don't really learn, in fact, in courses of science and management. What does this have to do with Europe? Well, in Europe, we've been criticized for being too theoretical, and that's a mathematician saying this. Theoretical even in soft matters. And maybe this has a point. Well, it's changing quite fast. We can see that we change our approach in institutions like, say, Polytechnique. And, well, the latest generation can learn very fast. But it's a steep curve. How is it a steep curve? Well, look at this figure on the left. It's been provided by the head of the governing board of the European Institute of Technology. This is absolutely depressing. I don't know if you have ever seen that. What is it? It's the leading innovators by age cohort. So here you have the percentage of companies in the United States, Europe, and others which were created before 1925. On the right, it's after 75. So look at this very tiny thing. This shows you how many of the leading innovators in Europe have been created in the last 30 years or so. So what is even more interesting, because we could be just depressed, but what is even more interesting, I think, is this in the same paper. The ratio between the R&D investment and the sales. Overall, in the United States, it's 4%, Europe 2.5%. Well, it's different, but not so much. For the younger companies, that is after 75, it's 7% in the US, 1% in Europe. So there seems to be some kind of positive correlations between the weight you put on R&D investment and substantial and the potential for innovation and growth. I mean, maybe you think it's obvious. It's not at all. I'm hearing the contrary all the time, that innovation success is not linked to R&D. So just food for thought. About entrepreneurship, well, what we observe is that there's been a steep rise in the percentage of young graduates from Europe who want to launch a startup. That's something quite new. Startups are not the only source for innovation, of course, but they're an important one, and that's where probably the European market is lagging behind the most against the USA and other regions. So it's good news that there are more young European people with an entrepreneurial urge, but of course the challenge for us is to keep them, well, most of them in Europe anyway. And for that, well, I'm not naive again. I'm not going to take this for granted, but I thought it interesting that the Legatum Institute in Dubai made a ranking of the most, how do they say, yes, the best countries for entrepreneurship and opportunities. And first 9 was in Europe, well, Northern Europe, but in Europe. Number 10 was Hong Kong. So again, of course, it's just one study and one set of criteria, but what it suggests is that we have some assets. We have strong technological infrastructure. We have rather good scientific education for engineers and also even for many of our business students. But we have to analyze, of course, the weaker points. We have bottlenecks for entrepreneurs. The financial support is there. We do have money for entrepreneurs, but not always at the right time and the right place. And also, if you create a startup and it grows, you don't have so many options in France to resell it or develop it to the next stage that you might have in the United States. If we manage to develop that, maybe we have good reasons to try and remain the race for innovation, even radical innovation. So that's where we come to the European Institute of Technology. I would have liked to give you a history of these things. It's somewhat funny, but we don't have time for that. What is European Institute of Technology? It was created by the European Commission. The starting point was that in 2000, Europe wanted to be the leader of innovation in 2010. So it's somehow pains to say that now because we all know it has not been the case. But in 2004 or 5, there was a reaction from the European Commission, and they said, well, you can't just count on the goodwill of independent countries. You have to set policies and give new tools for Europe to organize its race for innovation. And so what was created was this European Institute of Innovation and Technology, which has as a mission to increase the sustainable growth and competitiveness of Europe, to reinforce the capacity in the member states, and create, that's a core mission, the entrepreneurs of tomorrow, and prepare for the next innovative breakthroughs. So this sounds very simple on paper. Of course, it had been attempted many times. And so you needed new tools to try to have a success this time. And what does the European Institute of Technology do? It selects topics which are of societal interest, where Europe together might have a better chance than separately. to make a breakthrough, and those create the KICs, the knowledge and innovation communities. So it launches calls for consortia. Each consortium has to include academic and business partners. Then it selects a consortia, it supports them, it evaluates them, it funds them, and then what is expected to do is to co-develop a European approach to innovation. Well, that part will take more time, but let's see what it's doing in practice for the moment. So forget the side on the left. The right side is the topics that have been selected. The first three were sustainable energy, innovation and communication technologies, that's large communication systems, and climate change. As I told you, that was not a surprise, but it was quite a challenge, no market. This year is going to be healthy living and active aging, so that's how the societies are aging, and with technology, with societal concerns, raw materials, and then later you will have food security, added value manufacturing, and urban mobility. So what is the principle of the EIT? If you're familiar a little bit with the funding agencies in Europe, we try not to be basically funding agencies. We want to co-construct and co-fund projects. So this means that a typical project from a KIC will be part of the investment at seed funding by the EIT. The rest will be provided by KIC partners. And more importantly, we don't ask them to come independently and set proposals and we say yes or no. No, it's partners who make the proposals, we work with them on the proposals, then we select the best, and after we select them, we keep working with them to develop the best products. So this seems very simple, but again, it's rather innovative, and it's a lot of work. Supposedly, we're supposed to be a self-sustainable business in 10 years' time, or maybe 15 years' time. It's not easy, because when you're used to having public funding, well, things tend to stop with the day you stop the funding. Well, we don't have solutions for that yet, but it's a challenge we have in mind. So Climate-KIC itself is one of the three KICs. It's the one which was selected to address climate change innovation. What is it? It started with 16 partners. Now it's 217 across Europe. We are located mostly in 6 national centers. Why? Because the partners can't travel all the time, if for only thing for the carbon impact. They have to meet regularly, and they meet in national centers. So I'm in charge of the French center, but I also work equally at the European level. And then we have a set of regions, so those 6 regions, which are in different countries, most of them. And I will come back to the difference between the regions and the nations. We organize along 3 pillars. So the main one is innovation, 50% of our activity, and 1/4 for education, 1/4 for entrepreneurship. So to describe very shortly, you heard of the triangle of innovations, that's research, education, business. For us, it's a pyramid because the government and the public bodies, for the reasons I mentioned, are key. And initially, we were seen as mostly academic. You can see in the bottom that this has changed. So the industry is 23% of larger groups and 26% of small and medium enterprises. So 50% is actually the best proportion of the 3 KICs. Then we have roughly 1/4 of universities and research institutes, and a significant part which is public bodies and NGOs. So public bodies, well, I hinted at that. What is key? We need regulation for public bodies, but we also need to be able to work not just at the national level, but also at the regional level. And at the regional level, what authorities are telling us is that they're a bit lost when it comes to climate plans. Because what happens to them, they have lots of companies coming to them and saying, I have wonderful technologies, won't you buy it? And each technology separately seems wonderful, but you can't invest on all of them. And if you make a choice, why would you choose this set of technologies rather than the other set of technologies? That's something we want to try and help them with. So we will design with them subsets of the technologies they have at hand and say, well, pack A is going to make you progress on this and this indicator. And you can go in this direction, but you won't gain in another aspect. Pack B is going to be better on the second aspect, but this means that the first aspect is not a top priority. So this means, well, this seems very, very easy. Again, it's quite some work. Well, they need us, we need them as well, because we develop technologies, we develop regulations, but until we have tested them on the ground, not as separate technologies, but as sets of technologies, we don't know how they are effectively mitigating climate change or how effective the adaptation is being done. One core issue, though, is that when you want to cooperate between private and public partners, you have to avoid the conflicts of interest. Just take an example. If you're an energy provider, you know the customers very well. You want to be part of the policy design at the regional level. But then the region will say, yes, but they are my providers. I can't ask them to design a policy and then take them as providers. So we, as Climate-KIC, are going to be the neutral agent there. We work with the company. We integrate that in models that are really assessed, that are really neutralized in a way. And then we discuss with the regions, and the regions can take those models. Let's come to the second group of the companies. Well, that's maybe not very kind for big companies, but there is a notion that in innovation, and especially disruptive innovation, SMEs might be more flexible, more risk-taking. Well, it's not always the case, but in many cases it is, because if you're a small company, you want to survive, you are absolutely going to preserve your competitive edge. A larger group might be less driven to that, but on the other hand, it's more steady, more stable. In 10 years, it's probably going to be there. And they have a capacity to integrate technologies coming from SMEs, for instance, to develop large-scale demonstrators. And that's what's happening typically in Climate-KIC. So the large groups come to scout for SMEs. They will look for the best ideas and observe maybe which one they could integrate in their growth strategy. But in many cases, they will just choose to let the SMEs live their life, remain very flexible. And that's also the view of the SMEs. Some of them would like to be integrated in larger groups, but many of them want to remain independent, flexible, have the freedom to choose the niche they want to be in. Also, in climate change, is going to be even more marked because the markets are not fully developed, I said it, because the giants of today are not necessarily the major actors of tomorrow. I mentioned interdisciplinarity in the first 2 words of my talk, so let's spend just 2 minutes on that. Interdisciplinarity is obvious when you think of climate change. Let's say, for instance, the drought risk, flooding risk, and land use are connected. That's obvious. But, and what does it imply in terms of disciplines? It's agronomy, it's water, chemistry, civil engineering, etc. But in fact, it's more than interdisciplinarity, it's systemic. What does it mean to be systemic? Maybe it's easier if I take the example of an aircraft. So if you are going to build an aircraft, many students think that an aircraft is mostly mechanics, so it's fluid mechanics and structural mechanics. In the industry, the mechanics are roughly 1/3 of the aircraft, of the aeronautical industry. So the rest is real-time systems, electronics, ergonomy, a lot of things. The point is, if you allow each of the experts to work independently, well, the one working on flight, on fluid dynamics might come out with a wonderful profile, but the only thing is that it's not operable from the cockpit. Then the experts in automation might come up with something very flexible, but if you're the passenger, you won't like it because it's going to be out of control. So, of course, I'm being a bit simplistic here, but the point is the optimal system is generally not a combination of the optima of each of the components. And then what it means for the researchers and engineers is that they should be aware of the cross impacts. They should be aware of the interactions with the other fields, both because there are limitations, but also because they can create synergies. And what is less obvious maybe is that you need system experts whose job is to really work on the integration on the interfaces from the beginning. And then you define together the global optimum and you work towards that. So in climate change, we do have some of those issues. And I'll give you examples of good ideas locally which can be, well, not so good globally. So there's one about CFCs, but let's not come back to that. Energy efficiency, if you want to mitigate your emissions, then you will want to work on the insulation of buildings. But if you already have an optimized insulation for the winter, let's say, if you add insulation at the wrong place, you might have a very negative impact on the summertime. And that's something that has happened in reality. Example number 3 is about forests at large scale. You all heard that forests were major CO2 sinks. Yes, they are, but do you have to replant forests everywhere to improve the CO2 emissions? Well, not necessarily. If you decide to suppress grasslands and plant forests instead, you have to know that the grasslands have a better albedo, so the reflection coefficient is higher. So depending on the kind of forest you have and the kind of grasslands, maybe by planting forests instead of grasslands, you're going to actually lose in terms of emissions. Then a second example, example 2, is blue and green policies. In a city, you have blue policies about water management, goes from the flooding to water purification to everything that has to go with water. Green policies are, let's say, the parks, green spaces, also the green roofs. You probably heard that it has happened in some cities, that at the same time you had fires on green roofs, which were not properly isolated, and flooding in the streets. So that's a bit extreme, but what happens is that people who design the blue policies and people who design the green policies do not work together usually. They don't even have the same performance indicators. So it's very difficult to bring them together and tell them, well, come to the global optimum, because everything they have developed so far has been independently and it's not compatible. So that's, well, just a few examples to show you that you need to develop also cross-sectorial projects. This was an example of a Climate-KIC project where on the roofs of the École des Ponts in the Paris area, they have developed typically this kind of blue-green mechanisms. Finally, for research, well, of course, universities are a key actor and a research center are a key actor. Interacting with scientists on innovation is not completely obvious. Well, many of them have drivers, of course, but there are reasons why taking time from the research can be difficult. If you're a top scientist, you are in a fierce international competition. There is pressure to progress and to publish. So what can we do to convince them of spending some time for us? We can try to carbon compensate. That doesn't mean that if you do a KIC project, we're going to fund your research, but that means that we can help you in your applications. We can provide you better students for your PhDs, for your postdocs. That means also that we can close the loop, because quite a number of papers have been published out of our projects funded by KIC. So this, of course, is the driver for a scientist. There is another important point, which is that innovation requires research, but a product is a product. What I mean by that is that, of course, as a researcher, you want to attain results, but then you will keep challenging them. If you launch a product, you can't tell the customers the next day, oh, I have a better idea. No, you have to live with the product the way it is for some time. This seems obvious, but it is really a bottleneck in innovation development. Let's keep the structure of national and regional centers. The only thing I wanted to say is that the regions are the places where we interact not only on the local level, not only as test beds locally, but also on the transition. When you have wonderful technologies, you want to know whether the society is ready to accept them. And the regions have agreed to be the laboratories for that. What happened when we launched Climate-KIC? Well, initially we were suspected of being just pure scientists and wanting to save the world. Then we decided to open to everything that had a definite impact on climate or that was strongly impacted by climate. If you think of it, it's almost all the fields of activity. So obviously we couldn't go on like that. It was very good for the initial growth, but we had to focus to have a major impact on some areas. And this is how we came out with the platforms. So the platforms are think tanks centered on each of those topics. To understand this diagram, you can see the adaptation side on the left, mitigation side on the right, and on the top the production, and on the bottom the lifestyles and livelihoods and cities. So as you can see, it's very diverse, but it goes from, let's say, land and water management and engineering to industrial symbiosis, reusing CO2 as materials, but also things that are very much on behaviors which are making transitions happen. So that's the way we're trying to focus progressively. The second step will be to build flagship projects, so programs which integrate smaller projects. And for instance, one is on sustainable smart districts. So we work with a district in a major city, and we try to integrate again the technologies we have developed and see how the district reacts. A few examples maybe of innovation projects, if I'm allowed to spend a few more minutes. So we have a range of projects. Some of them are quite technologics, such as this one, CarboCount City, is about counting more accurately what the emissions are at the level of a city, major city like Paris with all kinds of sources, or one like Rotterdam, which is basically an industrial port. So this is going to grow bigger. We're using satellite information to complete the data on the ground, and this is going to be discussed with notably a project from JPL within the megacities carbon project at a large scale. So what it means is we don't want to compete with the world, we also want to cooperate with other projects. Oasis is a different thing, is about insurers. So insurers say, yes, we all have an assessment of risks for extreme events, but the limitation is that we all hide what we have. And let's develop an open source catastrophe model that can be well, updated regularly. So the developer is Climate-KIC, but we are helped by 20 companies, insurance companies, who have accepted to play this game and go for non-profit sharing of information on this risk. Renewable jets is a different thing, so we are not working on biofuels. I think you heard sooner in the festival that biofuels were nonsense. No, we know that some biofuels are effectively working, and the question raised by our Dutch partners, the Amsterdam Airport and KLM, is whether it's possible to use biofuels existing at a large scale. That means targeting, well, the transportation, the providers, targeting the costs, etc. So this is a real-scale experiment, not technologic, but really economic on renewable jet fuels. This is another kind of project. This is helping the regional authorities to assess the risks. So let's take, for instance, the second one, which is PRECOS on the right-hand side. So this is about let's say, mostly water availability and natural resource availability. And the point is to be able to tell the region, be careful, you're reaching the tipping point beyond which you won't be able to adapt anymore, and you will have to go to more drastic measures. So it's really integrating data in real time at the level of a territory and providing the region with this. Let me go to entrepreneurship. Entrepreneurship is, of course, helping startups. We are funding them, but the difference with some mechanisms that are already existing is that we are more focused on the climate issues and we're challenging them. So this means that we are not just giving them money as seed money. We are going to work with them. Ask them, are you sure you want to go to those markets? Are you sure how mature they are or how not mature they are? Are you sure of the business development you want to target? Do you want to become big very quickly? Do you have the right competence mix? You have wonderful technologies, but you don't have the competence in terms of market development, for instance. Do you know something about IP, intellectual property? Are you defensive about that? So all these kind of very basic questions are addressed by our support. There is some success, so let's boost a little bit because you might wonder whether we're achieving anything. So you probably heard of the Clean Tech Open Global Ideas. So that's a competition held in Silicon Valley every year. Some call it the Oscars of Clean Tech Innovation. In 2013, they selected 28 startups worldwide. There were 5 finalists, and 3 of them were supported by Climate-KIC. Well, it's not so bad for a young consortium. So let's look at one of them just as an example. It's efficient city farming. The idea is aquaponics. So you both do aquaculture by growing fish, but you also do hydroponics by cultivating plants. And in fact, you use, for instance, the water coming from the fish pond for the plants, which allows you to, of course, nourish them. You improve the synergy in terms of CO2. And the fact is that you're going to provide a kind of key-in-hand solution, both for urban farms and for larger industrial farms in the countryside. Another example I like is this one. So the concept is to work on high-performance computing. So you work with people who need high-performance computing, and this is a growing market, as you know, biology, 3D finance, you name it. And what do? You actually send the computation to thousands of CPUs with a very low cost. It's secure because it's scattered mostly. And the CPUs are heaters for the customers who have them. This means that you are computing and you're heating for free thousands of houses. It's good quality heating from what I hear. And in fact, this is very cleverly done. It's not a completely new idea, but it's very cleverly done. It's very flexible for the computer client. For the radiator client, it's free and very good quality heating. There is 50% of the power which is permanently available for free for academic and scientific laboratories, and this helps to regulate the seasonal variations. So I'm not going into any detail, but you can be sure that they're starting to have very good contracts with banks and with 3D companies. Finally, let's go to education. Maybe you're interested in education. We chose not to create a master in climate science or in climate innovation to absorb all the others. Why? Because you need to know too much to really have a global vision of climate, and because what we would train would be people who know a little bit about everything but have no specific competence. What we do is select some master's programs in the landscape of our partners, those where we think that they're going to work in fields which are relevant to climate. And then we bring them together in summer schools. Those summer schools are turned towards entrepreneurship. They spend 5 weeks together in different countries. They have to talk with experts to see where the real challenges are, and they have to develop business plans over this period of 5 weeks. Well, some of them are really innovative. I can give you examples after the conference if you're interested. So that's not the only thing we're doing. In fact, so there is the journey, which is the summer school I just described, but we also have a mechanism for those who have already an idea for a startup but are not ready to go to an incubator, so give them mild counseling to go towards the incubator. We also have conferences by keynote speakers and success stories about Climate-KIC innovation, mobility mechanisms, and of course local activities. So it's a whole set, and maybe the most important thing that comes out of this education activity beyond the modules is the Alumni Association. Why? Because, in fact, the students understand that, especially if they want to have an impact on climate, they cannot stay alone. They have to find connections and complementarities. And this is working, and hopefully, for the moment, we have 500 alumni. Hopefully, in a few years, we'll have thousands of alumni on a lot of different sectors, but who are connected and aware of climate change issues in their future endeavors. So this is something that might interest some of you, actually. Most of the journey students are students from our partner universities, but a number of places are open for universities from all over the world. So it is competitive, I can tell you there are many candidates, but if you're interested, do contact us to know. Side lessons. That's the last part of my lecture. Side lesson learned in the process. There are differences between European countries. So sometimes it's a bit difficult. Let's say for rules, for instance, the British would tend to say, oh, all the good ideas are welcome, let's put them in the pipeline, start playing, and we'll see if we don't like the rules, we'll change them. In France, it's almost the opposite. It's, we don't know the rules, we're not going to start playing. Another example, which is more serious maybe, is the way you integrate applied research, innovation, and fundamental research. So in Germany, for instance, you have this set of research centers, Max Planck on more fundamentals, Fraunhofer on more technological research. In France, there is a tendency to focus on blue sky research or go gradually towards applications. But there's also a new system of industrial chairs where a company will fund research over periods of 5 years on a more programmatic approach. So all this is, of course, hampering sometimes mutual understanding, but it's also a richness that you do not have in mononational organizations. So this is a lot, of course, of challenge in terms of simplicity. European organizations are supposed to be very complicated, but it's also very challenging and very stimulating in terms of schemes of thoughts and action. Other national differences, well, just to name one, on energy, you know that 75% of electricity in France is produced through nuclear plants. And in Germany, there has been for several decades now a massive rejection of nuclear plants. There are plans to stop them altogether. So how do we work with, let's say, the nuclear industry which wants to join Climate-KIC? Well, we try to find arrangements and sensible solutions. So what I want to say is that there are many ways to work transnationally, and it's also a message for you students that it's not the same thing to be in a multinational place like this, where you meet students from all over the world, or to work with teams where everybody is in a different national context. Because when you come here, you are ready to adapt. When you work in a team where there is one German, one British, and they're each in their countries, they're not always ready to compromise. And this is a very different experience. So if you have the opportunity to go abroad at some point, do try this as well. So finally, this is the last slide. Why are we doing all this? And some will say, yes, you're doing this because secretly you want to save the world. I would say, well, why not? Why not after all? I mean, if the world is in real danger, that might be a noble driver. But what we have to avoid, of course, is confusion between our ideals and economic viability. As Climate-KIC, we have a responsibility to deliver things that are economically viable. Naivety is not a very good driver. You can engage people on a large scale on very simplistic ideas, but then when they find out that it's more complicated, you've lost them forever. the sheer scale of the challenge is enormous. We can't achieve it alone, not even at a European scale. But fortunately, we're not alone in the world, and our intention is not to spread to the whole world, but to maybe discuss with emerging new networks in America, in Eastern Asia, in Africa, why not here, and work together in compatible ways, try to develop things in parallel and not competing. So remember, Climate-KIC is only planting seeds. We are quite happy of what we have been developing over the last few years. That's what we hope to do. I hope you liked it. So if you have any questions, feel free to ask them. Thank you for your attention.
It's working. So I'm Georgi Stenchikov. I'm working on environmental problem, including climate. So the question is about energy. So we know that this is the major reason. If we have enough energy, we will solve the problem. So about nuclear power. So in France, and how you look at nuclear power from the point of view of climate change, because in this sense it is clean.
Sorry, that would be better. Yes, what I was saying is that we're not concerned primarily about energy production, but about the use of energy and its impact on the climate. So indeed, in practice, one of our core partners at the French level is the CEA, which is the Commission for Atomic Energy. So now they are also on other kinds of energy, but it does include the atomic energy. A company like Areva, which is a producer for nuclear plants, has some plans of joining us. So far it has not been a problem in the sense that, yes, indeed, it is one of the realistic possibilities to reduce greenhouse gas emissions as compared with fossil fuels in the future. However, we have to take into account as well the fact that even at the French level, there are new policies which are being voted, addicted right now, to reduce the share of electricity produced through nuclear energy to 50% instead of 75% now. So I would say in the short term, there is no problem for us to work with nuclear companies. Maybe we won't involve many German partners in those parts, but we do work with them. However, there is some limitation in the development we could make in that direction. I would say we have more projects and more ideas coming from renewable energies such as solar energies, wind, marine energy, and so on. But in terms of scale, yeah, of course it's a huge debate, but in terms of scale, there's not up to now realistic short-term replacement for nuclear energy if you don't want to go to either coal or oil. So yes, we try to be pragmatic about that.
You've mentioned that you're not a granting agency. You're not competing with all the major three-letter or four-letter acronyms in Europe and U.S. and so. But what is the magnitude of the investment? Is this mostly demonstrator projects, which you hope larger budget organizations will come around to and replicate, or is there actually a plan to accelerate the investment in them directly through this European Union consortium?
Really depends of, let's say in innovation, in fact we have two scales principally. We have those so-called Pathfinder projects, which are pre-projects where a number of different development paths are envisioned, and that would be rather funding a market study, really. But that can be a market study with technological, societal, regulatory aspects. And then you have the fully fledged projects. So some of them do include a dimension for demonstration. And of course, if the scale is very large, we expect one of the partners to be co-funding. But many of them will be, let's say, typically in the scale of 1 to 3 or 4 million euros for over 3 years. So with that, you can actually maybe not fully develop a demonstrator, but you can go to address technological bottlenecks and also assert the viability of your solution. Now we're going, as I mentioned, towards a flagship project. So for this, the kind of amounts envisioned is rather of the order of magnitude of 10, 20, maybe more million euros over 5 years. But the expectation is not that we're going to build giant projects, but rather sets of projects with synergies between them. So one thing the EIT has been very clear about not funding is infrastructures, for instance. So that would, I mean, eat most of the budget, and that's not what we're going to do. For startups, of course, the scale is not the same, and we try not to flood them in easy money, so to speak. So it can be up to 100,000 euros in direct support. They don't have to repay it, but basically this is going to go with the number of actions we want them to make.
So you mentioned the instrumental role of the European Commission, the role of public organization and private and so on. But would you one day approach Warren Buffett or Bill Gates or Mrs. Betancourt for donation, for instance? Or would they be interested in donating for this?
Yes, that's two different questions, unfortunately. So the first one, yes, definitely it's one of the paths we're starting to explore. Well, partly through personal contacts of some of our members, but also because we know that the funding from Europe is guaranteed until 2020, but probably not beyond that. And of course, we might envision taking equity in startups. We might envision also developing consulting activities and so on. But the general feeling is that it's not going to be the major part of the funding. So yes, of course, we have one model which is common sense, which is to have maybe three structures: a core structure being this kind of motor for innovation, the engine that keeps innovation money flooding, then maybe a venture fund or a fund of funds, and then a donation fund. But it's quite possible that we would rely on existing ones. For the moment, we have among the NGOs, for instance, at a very small scale, WWF in Switzerland, which is involved. So they're both a little bit influencing the agenda, of course, but very mildly. But also they have this, well, it's a kind of small prototype of what we could do with donations. Well, Bill Gates, we haven't discussed with him so far. That would raise issues such as, do you like geoengineering? Do you want to send sulfur in the atmosphere and these kind of things? But that's a different story.
What is European view to geoengineering? So recently, regarding to climate change, it is discussed artificial ways to decrease temperature, for example, to put aerosol in the stratosphere, like volcanic eruption do, or make clouds more reflective. What is European view to this? No, what is the opinion in Europe about these geoengineering techniques?
So at the individual level, I'm sure there are people who are favorable to that. In our team, we have one person who is a fan of geoengineering. Globally, I would suspect that there would be very strong resistance to geoengineering in Europe so far. Maybe it's a handicap we have as societies. We are ready to take risks, but this kind of risk on the effects, there has been some experiences of not comparing something that's not comparable, but I think what happens with CFC is still in memory. So CFC ban was, of course, in a way an international success of bringing governments together, but then the impacts in terms of climate were very debatable. I would suspect that when it comes to long-term effects on such factors which are not completely mastered in terms of climate science, there would be a lot of reluctance, and the way I see the public decision in our societies, I would suspect that it's a difficult path to take. Now, honestly, we can't guarantee that there won't be an acceleration in other places in the world of these kind of technologies, and we would need to react. I suspect we won't be the first to go there, but I may be wrong.